Hi, my name is Kimberly O'Neill. Again, I'm a math instructional specialist in a district in Houston, Texas, and welcome to another video blog. This blog is going to focus on a fifth grade readiness standard, 5.3K, which if you have had any dealings with this, you know that it's been quite a headache for a lot of teachers. And rightly so. I mean, the standard talks about the adding and subtracting of rational numbers fluently. And so some teachers have asked, well, what does a rational number entail? And some have said, well, what do they mean by doing it fluently? And so, not that I'm going to address those explicitly here, but I am going to show what I'm showing some of the teachers that I work with. Now, these questions are typically tested in considering of how they're tested, are going to be asked using word problems. But I'm just going to look at the basis of how the students to manipulate fluently with the numbers from those word problems. So ideally, I would start by exposing the students to just simple computation problems that entail decimals and fractions. And then we're also going to look at fractions and decimals, just doing it the opposite way. But any of these 5.3K problems can be adding decimals and subtracting the same, or subtracting and adding of fractions and fractions. The ideal is for them to be able to use some of the concepts that they've learned, especially with decimals in like fourth grade, and be able to do that quickly without the actual skill of learning how to do it, just to be able to do it. And then with fractions, they've been able to do that with like denominators. And now in fifth grade, they're learning how to do it with unlike denominators. So they just want them to be able to embed that into a word problem. No picture models, no number lines, anything like that. Just be able to do it. So but there's going to be some times when there's a fraction and a decimal in a problem. So this is what I share with the teachers, that because this is their first time doing the adding and subtracting of rational numbers fluently, what they need to be able to do is work with decimals that can easily be converted into fractions. So for example, I have 3/10 here. 3/10 they learned in fourth grade on a number line is equivalent to 3/10. Okay, so students need to be able to say, oh, I recognize this decimal 3/10. Let me substitute that decimal for this fraction 3/10. And now I can go back to what I just learned probably a few weeks prior, or if your district embeds the TEKS, that what they're going to be doing now is adding fractions with unlike denominators. So students should be able to say, well, okay, let me change. And if I had my pen, what I would do here then is just write, times one whole as two halves, and then changing that into 6/10. And now I have substituted the 3/5 for 6/10. And then I can go back to adding 3/10 plus 6/10 equals 9/10. And then I have my answer there. Okay. So that's one way. Now, students, the more they work with this, they need to be able to come up with what works for them. Because obviously, let me just put this problem back. If students say, well, I feel like I'm more fluent with adding decimals, and they may not use that term fluent, but what's easiest for me, and so that's what they mean by fluency. What is easiest for you to add, fractions, or is it easier for you to add decimals? So if it's easier for you to add decimals, then let's go back to where we changed this 3/5 and we substituted it for 6/10. Now students need to go back again to their fourth grade knowledge and say, okay, if I look at 6/10 on a number line, what decimal is that equivalent to? Well, that's equivalent to 0.6, or 0 and 6/10. And now my problem is 3/10 plus 6/10. And then they, if they're using the strategy of lining their digits up, then they have their sum of 9/10. Okay. And then let's consider, if you will, that again, we're dealing with fractions and decimals, and we expose students to another problem. Now we say fluently, you want to either change your fraction into a decimal or your decimal to a fraction. Which is easiest for you? Well, for students who recognize tens, thinking back to fourth grade, they're going to say, oh, I know that 6/10 is equivalent to 0 and 0.6. And so great. Allow them to add those up and get their answer. That is what fluently works for them. The great thing about the new standards is that students are allowed to use the technique that works best for them. We just guide them and facilitate them into what they feel is best. But we need to teach them both ways, as opposed to giving them some type of rigid structure as to what they're supposed to do. But you may have your students who say, well, I can really dig the adding of fractions, so I know that this 75/100 is really equal to 3/4. Now, if you have students who don't know the benchmark fractions, this is a great opportunity to go back and talk about the benchmark fractions that they learned before, and really maybe even put up an anchor chart that helps them remember those fourths and halves and 3/4, things like that. Because those are the fractions, those are the decimals that they're going to be exposed to the most. They are not expected to divide 3 by 4 in order to get 75/100. What they need to know is those benchmark fractions and fluently be able to translate 75/100 into 3/4 and vice versa. So then at this point, they would look for their common denominator of 20, change this into 12/20ths, change this into 15/20ths, and then go from there as far as adding the fractions. So again, 5.3K seems like a beast of a teak, but really we want to just expose students to adding and subtracting decimals quickly, adding and subtracting fractions quickly, and then when there's a situation where there's a decimal and a fraction involved, is the students finagling and deciding which is more comfortable or fluent for them to convert the fraction to a decimal or the decimal to a fraction, and then from there I would go into word problems and really exposing them more to those concepts within a word problem. So I hope that helps you out.